Hi guys, it's Mr. Mustafa here. In this video, I'm going to show you an easy method for differentiating trigonometric functions. So how this method actually works is by making use of the summary here, which is sec tan, cosec, negative cosec, cot. So if I differentiate sec x, I get the other two, which is sec x tan x. And if I differentiate tan x, I get sec x times sec x, which is sec squared x. Similarly, if I differentiate cosec x, I get negative cosec x cot x, in other words the other two. And if I differentiate cot x, I get cosec x times cosec x, which is negative cosec squared x. Right, now of course you have seen these proofs where we can use the quotient rule for tan x. To differentiate tan x, we can write it as sin x over cos x and then apply the appropriate quotient rule, and we should end up with an answer which is sec squared x. Now obviously if you have to apply the quotient rule, you need to know the other two trig derivatives, which is d dx of sin x. The derivative of sin x is equal to cos x, and the derivative of cos x is equal to negative sin x. One more important thing to note here is that whenever you're differentiating something starting with a c, there's always a negative, right? In other words, if I have to differentiate cosec x, I will get negative cosec cot. If I have to differentiate something starting with c, in other words cot x, I will get negative cosec squared. Now let us differentiate some examples which I have on the next page. Before I continue with this video, please don't forget to subscribe to my channel for more content. So the problems that we are going to be differentiating in this video are these 6 problems here. So let us start with example number 1, which is basic. We want to find the derivative of cos 2 theta. So dy d theta is equal to, right? Guys, I just wanted to say one more thing, is that in order to do trigonometric functions, what you need to know is your basics, which is you need to know your quotient rule, right? You need to know your product rule, right? And you also need to know your chain rule. So these are like all basic problems, right, which I have on the previous page here. So I am on question 1, right? So question 1, we want to find the derivative of cos 2 theta. See, starting with the c, so there is a negative sin 2 theta, and don't forget to differentiate the inside, which is times 2. So this is your answer. You can carry on simplifying after this. Let us look at example number 2. Question 2. So we have cot 5 theta squared minus theta. Now cot of 5 theta squared minus theta, the derivative of cot is negative cosec squared. So we are dealing with this line. So dy d theta, remember we're finding the derivative with respect to theta. Let me just see, yes, okay. Dy d theta is equal to, derivative of cot is negative cosec squared of the argument, which is 5 theta squared minus theta, times the derivative of the inside, which is 10 theta minus 1. And of course you can take this and bring it in the front, right? So it becomes negative 10 theta minus 1. Write it in neat form, right? I'll just leave the answer like this. Question 3. Y is equal to cosec 10 theta cubed, right? Y is equal to cosec 10 theta cubed minus 3 theta plus 5. Now since we're dealing with the derivative of cosec, we will get the other two, which is negative cosec cot. We will get these two, right? So let us go and differentiate cosec. So dy d theta, you can say y prime with respect to theta, or y prime theta, which is equal to negative cosec cot, and then obviously you need to differentiate this, so one more bracket, right? So let us write down the solution. negative cosec cot, so negative cosec 10 theta cubed minus 3 theta plus 5, 10 theta cubed minus 3 theta plus 5, and we have here the derivative of this, which is 30 theta squared minus 3, and then the derivative of 5 is 0. So you can go and simplify this further. Well, you can bring the 30 theta squared minus 3 just behind the negative, right? So I will leave the answer like this. Of course, you can go and simplify. Question 4. In question 4, we can say dy d theta is equal to derivative of sec cubed. Well, not dy d theta. Let us go and simplify. Let us go and simplify the y first. So I will write it in this form, which is sec 11 theta all cubed, and then I will apply the appropriate chain rule. See, in the previous problem, question 3, we applied basically the chain rule here as well, because you can make all of this equal to u, right? And then question 2 here, we also applied the chain rule. Question 1 here, we also applied the chain rule. It's more like a composite function, right? Now, if you're looking at this example over here, we got y is equal to sec 11 theta all cubed. You can say dy d theta is equal to, differentiate this using chain rule, sec squared 11 theta, right? Well, I put the squared which was here inside here, so let me just take that out and write it on the outside. It's fine. So I'm applying the chain rule where we're subtracting 1 here, so squared there, it's fine. Now differentiate the inside here. If I have to differentiate the inside over here, derivative of sec is sec 10, so sec 11 theta tan 11 theta times the derivative of 11 theta, which is 11, right? And then of course you can simplify. Let me just simplify this. There's too many terms here. Sorry, there's too many expressions here, so just simplify this. What we have is, well, 3 times 11, everything is being multiplied by each other, so 3 times 11 is 33. We got sec squared 11 theta and sec 11 theta, which is sec cubed 11 theta times tan of 11 theta, and this is a nice answer. Let us move on to question 5. Right, so in question 5, what we have here is tan 3 theta over sec 5 theta. So we can apply the appropriate quotient rule, right? Quotient rule. So differentiate the top, leave the bottom, subtract, differentiate the bottom, leave the top, over the denominator squared. So we're going to write dy d theta is equal to, differentiating tan 3 theta using this rule, we will get sec squared 3 theta. Then of course we need to differentiate 3 theta, which is 3, and leave the bottom, which is sec 5 theta, subtract, differentiate sec 5 theta. If I have to differentiate sec, I will get sec tan sec 5 theta tan 5 theta, right? And then of course differentiating the 5 theta, I will get times 5, and don't forget to leave the top, which is tan 3 theta. You don't have to put it in bracket, just put it times 3 tan 3 theta, don't forget that, all over sec, square the denominator, sec squared 5 theta. I can see some like terms here, and you can go and simplify. What we have is a common factor of sec 5 theta on top, where sec 5 theta there, right? And you can go and take out one sec 5 theta from here, so this one disappears, and you should have some neat answer there, right? Let us move on to the next question, which is question 6. In question 6, what we have here is 3 theta times sec 3 theta. So we have a linear function multiplied by a trigonometric function. We will use the product rule. So dy d theta is equal to 3 derivative of this. So how the product rule works is differentiate the first, leave the second, plus differentiate the second, leave the first. So 3 times sec 3 theta plus differentiate sec 3 theta, I will get sec 3 theta tan 3 theta times 3, don't forget to multiply by 3, and then times the 3 theta. I'm sure we can see some common factors here, which is 3 sec 3 theta. We can take that out as a common factor. So we got this and the 3 there. Right, let us take this out as a common factor and simplify. Right, so I have 3 sec 3 theta as a common factor, and I'm going to simplify this and just use another color. So we have 1 plus 3 theta tan 3 theta, 3 theta tan 3 theta. Right, so I hope you understand these 6 problems, guys, and if you have any further questions, don't forget to leave comments right in this video. Thank you, guys. All the best.